Hey everybody, this is Mr. McKee again with Net 226. Today I'm going to be going over Packet Tracer 10.3.4, which is Configure and Verify NTP or Network Time Protocol. All right, this is a pretty fast packet tracer. There's not a lot to setting up NTP, but it's very important to have set up. So we'll go over it. All right, it's been a couple minutes since I started my .pka file, so it's converged already. I'm going to hit fast forward time just to be sure. All right, so let's go ahead and go through this thing. All right, in this activity, you will configure NTP on R1 and R2 to allow time synchronization. And one big thing about network time protocol, you want everything, all your timestamps to be synchronized for for security purposes, and also if something happened, you want to know exactly when that happened. All right, so that's important. All right, network time protocol or NTP synchronizes the time of day among a set of distributed time servers and clients. While there are a number of applications that require synchronized time, this lab will focus on correlating events that are listed in the system log and other time-sensitive events from multiple network devices. NTP uses user datagram, or user datagram protocol, UTP, as its transport protocol. All NTP communications use coordinated universal time, or UTC. An NTP server usually receives its time from an authoritative time source, such as an atomic clock attached to a time server. The NTP server then distributes this time across the network. NTP is extremely efficient. No more than 1 packet per minute is necessary to synchronize two devices within a millisecond of each other. All right, so let's go ahead and get started. Step 1, NTP server. Server N1, which server N1 is right here on the left, is already configured as NTP server for this topology. Verify its configuration under services NTP. All right, so services NTP. All right, it's turned on. All right, there's the time. And obviously that's not today's date, but that's fine. All right. So what we're going to do is from R1, which is out here, R1, we're going to go in the CLI, go and enable. All right. So from R1 ping N1 to verify connectivity, the ping should be successful. So we're going to ping 209.165.200.225. All right. Good responses back. You notice the first one failed because that did an ARP translation, but if I were to do it again, we'll get 5 by 5. All right, so that's normal. All right, so also it wants us to go ahead and repeat the ping to N1 from R2 to verify connectivity with N1. All right, so let's go up here, CLI, click in there again, hit enter, enable. All right, ping 209.165.200.225. We'll have one timeout. First packet. All right, do it again. We get 5 by 5, so we're good to go there. All right, and hopefully you guys can hear me. I'm trying to wear my my custom-made mask that my mother-in-law made me from an old piece of a material I had when I was in the military, and I want to see how it does. I've been wearing it around today just to try it out. I went to Walmart and Lowe's, and people seem to get a kick out of it, so that's good. Hopefully it works fairly good. It actually has a place where you can put a filter inside of it if you're so inclined to do so. All right, but anyways, all right. So step 2, configure the NTP clients. Cisco devices can be configured to refer to an NTP server to use to synchronize their clocks. It is important to keep time consistent among all devices. Configure R1 and R2 as NTP clients, so their clocks are synchronized. Both R1 and R2 use N1 server as their NTP server. All right, check the current NTP and clock settings as shown below. All right, so go to R1, show NTP status. All right, NTP is not enabled on R1. And then show clock detail. All right, time source is hardware calendar. And it says it's 1993. That was a while ago. All right, configure R1 and R2 as NTP clients. Use the NTP server command to specify an NTP server as shown below. All right, so let's do the R1 and go to privilege exec, and let's do NTP server 209.165.200.225. All right, so that's set. I notice my completion rate up to 50%, so that's pretty good. Let's go to R2. Same thing. Configure terminal and NTP server 209.165.200.225. All right, looks good. Completion rate's 100%. All right, in step 3, check the clocks on R1 and R2 again to verify that they're synchronized. So R1, let's go exit out of that, privilege exec mode, and then do show clock detail. And you know what? That's not right. That is not correct. It should be showing this time. All right. So let's fast forward time a little bit. So the up arrow. All right. So it wasn't converged yet, or it wasn't updated yet. So hit fast forward time. You notice it went from 1993, about the time I graduated from high school, to last year. So that's a little bit of difference. All right. Time source is NTP. Let's go to R2 and do enable, show clock detail. All right, notice that one's already updated. All right, so we're good to go. All right, so when working with physical routers, allow a few minutes before R1 and R2 clocks are synchronized. With Packet Tracer, you can use the fast forward time button to speed up the synchronization. And you notice I did that. All right. Did the same thing on R2. Are the clocks synchronized? Yes, they are. Matter of fact, and since there's only one question on this Packet Tracer, I'm not going to make you guys submit that question. Just submit your .pka file and your copy of your check results. All right. So check the NTP status and NTP associations by using the following commands to verify NTP operation configuration. And go to R1. All right, show NTP status. All right. And if you notice this stratum 2, that refers to how much, I guess, how much weight, you know, what ranking of the NTP that is. And matter of fact, while I'm thinking about it, because this, I don't know about the newer version 7 CCNA exam, but the older one, it did reference stratums. Stratum Cisco. Stratum level Cisco. Let me see if I can get a good diagram. Here's one example of this. Now this is like super complicated, but the lower the number, the higher the source, um, the lower the stratum number, the higher the relative ranking of the time source. All right, like a GPS satellite. Right here, a stratum 1 NTP server is a primary server connected to what is known as a reference clock, which is usually a GPS clock. All right. So stratum 0 would be like the actual satellite itself, and then stratum 1 would be the top tier of the server. All right. So a stratum 2 that's looking towards a stratum 1 for its time, it doesn't have as high a rank as a stratum 1. And the stratums go from, I believe, let's see, 1 to 15, or 0 to 15. Let's see if it says it. But anyways, the stratum is the reference like ranking of the NTP server. All right, but that's really it. I don't want to get too much into that. I just wanted to reference that. I don't even know if it's on the new exam, but the lower the number, the higher the relative rating of the stratum or the NTP server. Let me look at one more thing. Let's see. Anyways, I don't want to make this video too long. I know it was quick anyways, but just remember this: the source is 0, and it can go all the way down to 15. All right, and that's it. Thanks for watching, and only submit the .pka file and the screenshot of your activity results. Hopefully everybody gets 100% on this, because literally it's only 2 little configs you put in there. All right, that's it. Thanks for watching.